Let's do this beast. All right. So the first section we did, we talked about what to do if there's like a power. We took it to the reciprocal power to get rid of the power. Right? That was a long time ago. This section, what we're going to focus on, how do we solve equations? How do we solve equations when we have the variable as an exponent? Okay. And I'll give you a hint. It's going to be all the same steps you've ever done to solve with one new step. Okay, we're going to learn one new step. We're also going to learn how do we solve for variables if we have logarithms. How do you get rid of them? And that one, again, is going to be one old step different. But this is going to be very new to you, probably. Yep. Yeah, I messed up the numbering on those pages. 6, 6 actually starts. I don't know why I went 6, 6, 6, 7 in a row. All right, the first type of problem you can see is when you match the bases. Okay, the first type of problem you're going to see is if your bases are the same, you set the equations equal to each other. Okay, and those ones are going to be really, really basic. The same is true if the exponents are the same, set the bases equal to each other. If the logs are the same, set what's inside equal to each other. And if those are the same, set the R2 equal to each other. This is going to make a lot more sense when you see a real life example. All right. So, what do you think you can do with this equation? Do you think you have to do anything fancy? Or can you look at it and say these are both 5? So I can set the exponents equal to each other. This is what the first one in the homework looks like. Okay. You guys see that? All right. So now it's just good old-fashioned algebra, right? Minus 2x, minus 2x. I get negative 12 equals 3x. So x is negative 4, right? You guys can probably do that part. That's just basic algebra. Uh-oh, number 2, they don't look exactly the same. Can I make it so they both are a power of 2? I can. Now, I will say we will learn a tool later that you don't have to be able to do that. But for these, it's a lot less work. To say 2, think about this, 2 to what power equals 8? This one's common. It's 2 to the third equals 8. Okay? And when it's a power to a power, what do I do with those two? Do I add them or multiply them? You multiply them. So that's the same thing as 2 to the 3x equals 2 to the x plus 14. And then what can I do? If the bases are the same, set the exponents equal to each other. And you'd get x equals 7. I skipped a bunch of steps there if you're okay with that for the basic algebra. But the big thing is once the bases are equal, set the exponents equal to each other. Okay? So that's, with that information, you can do number 1 on the homework. Some of you guys might have tried it. All right, all right, all right. Oh no, look at this. Are they being taken to the same power? Yeah, they're both being taken to the 7th, right? As long as those are the same, what do I know has to be true about these two pieces? They're the same. 9x minus 1 equals 8x plus 8. You guys see where I'm getting that from? This one you'd get x equals 9 if you solve it. Okay. How would you guys do the next one? Be careful with logs because what has to be true about this number down here? They have to be the same, right? So since they're both log base 3, I can set the equations equal to each other, right? And this one you get x equals 5 if you go through and solve it. You guys okay with me skipping the algebra 1 parts? All right, good. It'll save us some time. And there we go. All right, sorry about that. So let's go on. What are we going to do? What do we do if the bases aren't the same? Do we just quit and we say we can't solve them? Do we just ask ChatGPT? ChatGPT really actually struggles with this. It does. It does. It struggles. We use our properties from before. There's 2 big properties that we're going to be using a lot of. If I saw something like, if I had 7 to the x, and I want to get rid of that x, if I natural log it, what can I do with that x? Move it in front. And now my x is part of my equation. Okay, so we're going to use the properties of logs, that power rule, that a power moves out in front when I natural log it to get rid of powers, like to move them in front. This rule we're going to use the most. Okay, we need to get rid of exponents. How do we get rid of exponents? Logging. Logging is always the answer. That's a log. That's the natural log. Nice piece of oak. Just kidding. I don't like to build out of oak. All right, let's solve these beasts. All right, first step always, and it said it on the first slide, but first we need to isolate exponent. Okay, so we need a number to an x. That's all we need. We need to iso it. And then second, we're going to log both sides. That's going to be my advice. We're going to do that every time. Get the exponent by itself, log it, and then we just solve it with good old-fashioned math, good old-fashioned algebra. So this one, my exponent is not isolated yet. So what do I need to do to both sides? Bear with me. I was a bad student today. I forgot my notes at home, so I'm going to have to work it through as we go. I'm going to divide both sides by 4. I get e to the x equals, it's a decimal. I think it's 62.5. Yeah. 62.5. So my exponent's isolated now. It's by itself. Now I'm going to log both sides. I almost always use natural log. And I just get used to using it. I like using it. But what's nice about this, why would I use natural log with an e? Because what's natural log of e to the a? It's a, right? Those cancel. They have the same base. It's same base. So next step, I'm going to log both sides. Cut them down. I'm going to natural log. Those cancel. I get x equals natural log of 62.5. Now, this is where you're probably going to have a lot of mistakes on homework with rounding. And if you do, just let me know. Try to fix it. But when you're dealing with exponentials, if you round to the 10th place or 2 decimals in your work, you're going to get a completely different answer than someone who left log in their calculator till the very end. Because with an exponential, what do you know? Every little bit makes a huge difference. I always tell people, if you're doing this decimal way, you need to use 6 decimals anytime you're doing your work with it. You need at least 6 decimals. And I'm going to show you why on the decimals calculator, how big of a difference rounding makes with logs. And that's why it's important to try to keep it in as long as possible. Or try to not round. Ooh, that's the wrong button. I don't know what I'm doing. For this one, I got 4.14. All right. The next one's a little bit trickier. I need to isolate the exponent first. So I need to get this by itself, the e to the power by itself. So what do I do to both sides to get that beast by itself? Subtract 10. So I get e to the 3x minus 4 equals 1240. Just what time I eat a late lunch. Now, what can I do to both sides to get rid of the e and the exponent? This is the most important. This is the new step for you guys. What do I do both sides? Natural log it, right? If I natural log both sides, I end up with 3x minus 4, because those are going to cancel, equals natural log of 1240. Again, I'm going to try to leave that in my, I guess this one you can round. It's natural log of 1240. So if I treat this like a decimal, what I would suggest you do is change that to 7.1228667. Jeez Louise, this is wild. This is uncanny valley stuff. How many decimal places would I recommend you keep it? 6. This one won't matter that much, but just, I mean, 7 would be okay too. All right. Can we solve this equation now? Yeah, you guys can do that, right? Add 4, divide by 3. What was the only new thing we're going to do with all these? The log step. How do you get rid of an exponent? You log. Okay? So I'm going to add my 4. You get 3x equals 11.1228667. Divide by 3. And x is approximately. So what I do is I just leave the answer in my calculator and I keep manipulating that one so I don't have to worry about rounding as much. I got 3.71. Okay. You okay? Isolate, log both sides, solve. I got a bonus one for you guys today because again, I want you guys to practice this a few times before you do it. Try this one. If I give you 2e to the, let's 3x minus 4 equals 15. I want you guys to go ahead and pause the video if you have it. Go ahead and give that one a try. This one involves everything. All right. Big thing when you go through and do this one. So, big first step, did y'all go through and get 2 to the e to the 3x equals 19, add the 4, divide by 2. So at some point when you isolate it, you should get e to 3x equals 9.5. Okay? Treat the e to the 3x like an x. Like if you're trying to find x, you would add the 4, divide by 2. Then what was our new step? You got to natural log both sides, right? Now for this one, what I would do, or what I did, so I didn't have to worry about rounding errors, is I just left this in my calculator and then divided both sides by 3. Okay? I got 0.75 after I did it wrong the first time. Nar, maybe. You guys are quiet. All right. So that's how I solve basic continuous exponentials. We will throw one curveball at you. Any crickets? Why is my screen so sad? It's feeling blue. All right. All right, let's take a look at more examples of this. Let's do more examples. This is important stuff. We're going to do a lot of examples of this. What do I need to do first? Divide by the 500, right? get the e by itself. Right? Y'all see that first step. What do I do from there? Natural log. Luckily, natural log gets rid of e's. Okay? Too bad it doesn't work on my grades. Ha. All right. Now again, I'm going to try to leave the natural log of 7 and not round until the very end. Okay? Just remember, natural log of 7 is a number, not like an algebraic thing. You guys probably have as much room as I do to do this. Divide both sides by 0.07 and I get x equals something. 27.80 actually. Watch your rounding on this one, right? Because that number is 27.7987. If I'm rounding here, it'll go up. And that goes up, that goes up. I kid you not that my online in here, probably the biggest mistake made has been rounding so far this section. Rounding's been getting y'all. All right, let's try this beast. What makes this one different than that one? This one has an E. What's your base on this one? A 10. So am I going to use natural log on this one? I could, but I don't want to. Let's ISO this thing first. Let's ISO the exponent. Let's do our add 400. Right? And I get 10 to the 2x plus 1 equals 4,900. All right. Quick reminder, on your calculator, what does the log button, what's the base on your calculator? It's 10, right? So if I use my calculator and I push my log button, log base 10 on both sides, what happens to these? They will cancel, and I get 2x plus 1 equals log of 4,900, which that is on your calculator, right? If I don't write a base down, it's log base 10. Make sure you guys are trying this too in your calculator to get similar answers. This log button is busted. Because you should get, oopsie doodles. I got 3.690196. Okay? That's a number. And now I can solve it like an algebraic equation. Subtract a 1. 2x equals 2.690196. Divide by 2. Could I have left the log in there until the very end and done like log of, yeah, but sometimes people struggle with order of operations when you do that. So what I do is I hit log of 4,900 and I just take that answer, subtract 1, keep in my calculator, divide by 2, and I got x is approximately 1.35. Okay? Again, I know I keep saying it. What's the only new step we're doing here? Everything's algebra except when I bring the exponent down. Then treat it like an algebra equation, right? It looks messy, but it's just order of operations in reverse. What pretty colors. All right. So that'll get you through. Actually, you get a lot about exponents. All right, let's get really wild now. This should be this section's almost all just examples, which is good. Uh-oh. I don't have a log base 2 button on my calculator. Is there a way for me to cancel it? Maybe if it says something wild on the internet, it'll get canceled. Is that a thing? Sorry. All right. What do I do if there's not a log base 2 button on my calculator? I have log base 10 and natural log. Those two I can get rid of. There's two ways to do this problem. The one way is using change of base formula. I do not recommend that one. You can. Dr. Webster's video goes through it. Here's what I would do. Is my exponent isolated? Yeah. So what do I need to do to both sides? Log it. Does it matter which log I use? No. I'm going to natural log both sides. Okay. Now, when I natural log it, what happens to my exponent? Where can I move it? It moves out front. Right? Now remember, is natural log of 30 a number? Yes. Natural log of 2 is a number? Yes. And this is just x times a number. Like, it looks really scary. This is just a number times x equals a number, right? So what am I going to do to both sides? Divide by that number. Divide by that number. And then plug that in your calculator and see what you get. We just proved the change of base formula, by the way. I got 4.91. Oopsie doodles, don't write the equals. That'll bother me. Because what's change of base formula say? Because I said that's the way to do it, is log of the top. Because I could on log base 2 of that cancels, and you get x equals. Don't write this if you don't want to, but you could have done, I guess if you like it this way, I could have done log base 2 on both sides, right? And then those cancel, I get x equals log base 2 of 30. So you can do it that way, because then you use your change of base, which is say you take the natural log of 30 divided by natural log of 2. So I guess the choice is yours. The only reason I use this way more is it will work for any sort of complex problems we have. I guess this way will too, if you get there isolated. So I guess it's up to you. Do you want to do it this way and use your change of base, or this way? There's the same number of steps. It's up to you. I'm going to do it this way because it's more algebraic in my brain. If you like the other way, you can do it that way. Ooh, you're gaining 4% a year. You have Robin. Ooh, that's Robinhood's if you have money in there. Don't, not. Is this isolated yet? No. So I got to ISO it. Always ISO. ISO kick out. Ruin the NBA. No. All right. So I get 1.04 to the x equals 5.6 repeating. Eep. I want to keep as many decimals as possible. I could have left it as a fraction as well. I could have left it as 85 over 15 or left it in there. It's really what you're comfortable with doing. If you like just getting a decimal, not worrying about fractions, that's fine. What do I do to get rid of the x? Or what do I do? I could use log base 1.04, or I could just log both sides. Okay, I'm going to log both sides because that's the way I learned it growing up. And I'm a creature of habit. So I'm a natural log 1.04 x. How many times does that come up today? I'm proving that it's evil. All right. X moves out in front. You have to write all this. That's x times a number. So I divide by said number. And I get x equals something. 5.6666666 divided by natural log of 1.04. What do you guys get? Can we do it? Yes, sir. 44.23. Okay. I don't know. I like exponentials. They look really complex. Oh, we're doing perfect for time. All right. I'm going to show you guys why rounding matters here on this next one. Because I got to show you these because we might see a compounded monthly question. Gross. All right. Look at this. Ew. What can I do with that right now to make it look better? Botox? No, I'm just kidding. Don't put poison in it. Could I convert this to 1.003333? If you want to do it that way, you can. If you want to leave it that mess, you can as well. What else can I do before I move it down? Should I divide both sides by 1200? Probably. Probably, because we got to get that isolated. $25. Well, that's nice. So that question looked gnarly. Piece by piece, right? Piece by piece, step by step. Once that's isolated, what do I do to both sides? Log them. I'll log them. So this is going to move out in front. 12x times natural log. Oh, this marker's not easy to see. Okay. I'll switch to a different color. ADD. Now what do I do with that 12x? Could I divide both sides by 12 times natural log of 1.003333? Right? Because that's 12 times x. I'm just eliminating my 12. I'm eliminating my natural log. Now I'm going to show you in Desmos why rounding matters so much. Or why you got to be careful. I was meant to do that problem somewhere else. All right. Can you guys even see that? All right, up here's my little calculator. So if I do natural log of 25, right, divided by, I don't need to put that, thank you for the fraction bar, 12 times natural log of 1. Do you see how it's giving me an answer right now? Wait, why is it doing this? There it is. So I got 89.55 right now. But watch this. What happens when I add another 3? I got 81.42. Watch when I add another 3. 80.69. Add another 3. 80.61. Add another 3. 80.61. So do you see why I'm saying why you need to have 6 decimal points? Because when I got to 6 decimal points, did it move much from this one to this one? Nope. Because now when I keep adding them, it's going to keep being 80.61. So please, 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 if you want to get right in the homework, how many decimal points do you need to use? Oh, you guys can't see it. So the difference between using the 1, 3, my answer was 89. You know what I'm saying? When I had the 4 3s after, I got 80.61. So that's how big of a difference that small fraction makes on exponential functions. Okay? Again, 1.003 got me 89.55. 1.0333 got me 80. That's a big difference, okay? 6 decimal points will get you there. So watch out. So the answer is 80.61, approximately. Okay? So be careful. Yeah. Think about that now if you're investing your money in something that gives you percent return, how big of a difference a 0.5% is. It's a lot. Banks give 0.035%. Yeah. Yeah. They give it a fraction of a 1%. All right. So how do I deal with logs? Solving logs, I think, is actually more straightforward than solving exponentials. We can use the definition of logs or use the opposite property. So let's solve logs. Yeah. This was a lot today, but we're okay. Quick reminder. Log base 3 of 3 to the x is x, right? By the same definition, if log 3 to the log base 3 of x also equals x, right? They're inverses. So how do I get rid of a log with a base of 3? I make both. I take both to the power of 3. Or I could use the definition of 3 to the 5 equals the inside. Both are the same thing. But if I do take both as a power of 3, that will cancel, and this becomes 2x minus 7 equals 3 to the 5th. Okay? That's the way some books teach it. I just use the rule of logs, like the 3 to the 5 equals the inside. This one, though, we're going to isolate the log, ISO the log, and then take an exponent. It's like the opposite. Instead of isolating the exponent, take a log, we're going to isolate the log, take an exponent. It's just is wild. That's 243. Yeah. So 2x equals 236. No, you'd add it. 250. And x would be 125. Okay? ISO the log, power it. So we need to get that log by itself. So 5 natural log of x equals 27. Divide by 5. Sorry, I keep going all over the place. I run out of room. So I get natural log of x equals. Now I can leave it as a fraction. If it repeats, if it does, how many decimal points do I need to use? 6. At least 6. But that's 5.4. So it terminates, so that's fine. Like I'll be terminated probably someday. For my job, not like I don't want to be morbid. Now that I have this isolated, how do I get rid of natural log? What's my base? E. So x is e to the 5.4. I got, if you want decimals, 22.1.41. I'll be honest, in calculus, you're just going to leave those as e. You rarely change an e to a decimal. One more slide. Are we going to do it? Yeah, we are. That was a lot. This is the longest lecture of this unit. Most examples. But that's good. Examples are good. You'll have a lot to look at. All right. Mamma mia. That's a lot going on here. Can I just take everything as a power of 3? I need to get this down to 1 log. I need to isolate to 1 log. Luckily, what can I do with that subtraction? What does that mean? Subtraction is division. So can I convert that top equation to 1 log? I can, using my log properties. Now my log is isolated. So I'm going to take both as a power of 3, right? So now I'll cancel. I'm matching the hatch, matching the base. So I get x over 5 equals 3 squared is 9. Times by 5. X is 45. I did that relatively quick. You got to get down to 1 log. 2 logs is too heavy to carry. All right. 2 ways to solve this one. Way 1 I could do is I could just take both as a power of e right now, right? You know what I'm saying? I could. That's probably the way I would. Could I move that 2 out in front and divide by 2 first? Yeah. Let's get rid of this. That's what I would do. So 2 natural log of x equals 6. Now, if I didn't see it, would I be done? Would I be cooked, as the kids say? No, because when you go to, you get e to the 6 and then square root it. And when you square root something, you take half the exponent, which would be 3. Just remember, you can't have the negative answers for this. But I would move the exponent up front because it's a lot. Isn't it a lot easier to divide something by 2 than to square root it, right? Natural log of x equals 3. What's my base? E. So I get x equals e to the 3, which is something. 20.09. Phew. There we go. Then that was a lot. That's a lot of examples.